last but not least, I hope. Hi, everybody. Thank you for having me, and thank you for hanging out with us today. I am Miroslaw Nagas. I work at OLX as lead SRE, and today I will talk a bit about serverless, and I hope to prove to you that serverless is simply no joke. I have lots of slides, so I will speak quickly. But first things first, this is not a direct connection to the cloud. And in fact, there is no cloud. It's just someone else's computer. And what's even more, serverless runs on servers. Shocking, right? So what is this fuss all about? Is it a lie? I mean, is serverless a lie? Well, not necessarily. Serverless is one of those unfortunate names that confuse the hell out of people. What it really means is no servers for you to manage. And it's a bit like driving by taxi. There is a car involved for sure, but the car itself is not your concern. Taxi driver, this is a concern of the taxi driver, but not yours. So what is the serverless operational model? No provisioning or management of servers, that's for sure. It scales automatically, billing only for the usage, and things should be highly available and secure. So here is a typical microservices architecture. You have different clients, you have backend services. Between them two, you have some sort of API gateway or load balancer. Services talk to each other either through synchronous HTTP calls or asynchronous event bus. And they store information in databases. So let's start with the most cliche example possible, hello world example. If you want to run this piece of code on AWS, you can use Amazon Lambda for that. So how it works is you just upload your code, and Lambda takes care of everything to run and scale your code. So how to deploy that to AWS? There are four most commonly used tools. Serverless framework, AWS serverless application model, CloudFormation, and Terraform. So here is a working example written in serverless framework. The most interesting part is functions section, where you defined functions. We have here our hey function with proper handler. Let's deploy that. And here is the output from the deployment. And what I want you to see here is that under the hood, there is CloudFormation involved. So both serverless framework and AWS SAM uses CloudFormation, and they're tightly integrated with CloudFormation so that you can use CloudFormation definitions in both of them. Okay, our function was deployed. We see it in AWS console, and you can even test it there. We got the expected message and some additional information like duration and max memory used. You can also test it from using serverless command. Okay, so we covered the service part of it. Later on, I will tell you how to run Docker containers without any servers. But for now, let's see how we can make our code available to the world. In Lambda service in AWS console, we can see a designer section, and in that designer section, you can create triggers. And what are triggers? Lambda integrates with other AWS services, and you can configure trigger to invoke Lambda function as a response to some event, like, for instance, incoming HTTP request. And this is what I would like to show you now. So this is the current function definition, and this is a new definition. More or less, it means that that particular Lambda function can be triggered by some events and in this case, it's HTTP GET request to hey path. We can deploy that, and then there is another serverless command that you can use to show you some more information about your stack. And if you look at your stack in endpoint section, you can see some HTTP endpoint. If you open that, you will see the familiar hello world output. So what exactly happened here? If you look again in the designer section, you will see a new trigger. That trigger is API gateway. And if you look on the other side of the equation in API service in AWS console, you can see that there is a new resource, hey resource with get method, and when you call it, it will invoke lambda function. So what is API gateway? API gateway is a fully managed service that lets you publish, maintain, monitor your APIs, including REST and WebSocket API. It has lots of features, and among them is ability to integrate with, for instance, DynamoDB. DynamoDB is managed multi-master, multi-region, multi-everything key value and document database. They claim that it can handle 20 million requests per second, so sounds pretty good. And so how about getting rid of backend services for some particular use cases, and namely data APIs? So I'm pretty sure you are familiar with that. Backend code only as a proxy to interact with databases, adding records, listing record by ID, stuff like that. So let's see if we can do something about that. And what I mean is just get rid of this. You should. There is no need to have a backend service for that. So let's start with DynamoDB. Let's create a comments table, and then go to API gateway, and let's add a new resource, comments resource, that will integrate with DynamoDB. Let's deploy this API gateway stuff. And one important note, DynamoDB expects a certain request payload, like a certain format, right? And this is the proper format you can use when talking to DynamoDB. So let's use curl to add a new item, and let's scan DynamoDB to see if that item was added. And as we can see, it is there. So we were able to add item to database without using any single line of code. And what's even more, I will show you one interesting usage in API gateway. So here was the request payload we used, and as you can see, it contains a lot of information about, a lot of details about DynamoDB. It contains the table name, it contains key names, it contains the type and stuff like that. So let's do something about this. In API Gateway, you have integration request section, and if you go there, there is a mapping template thing. And what it does is, let's say, it changes API Gateway behavior a bit. So the request you do is not passed through to DynamoDB as is, but it will be modified according to the template. So for instance, we can have this template, and as you can see, command ID will be generated automatically from request context, and message will be taken from input parameters. We can use curl again. As you can see, in the payload, we only specify message and the value. We don't specify all the stuff we specified previously. And if we scan DynamoDB again, we can see that that object, that item was added with command ID taken from request context. And what you can even do more is you can also modify the response by using mapping templates. So that is an example of the template, and what it does is it transforms the response we had from DynamoDB, so from this one to something like this. And that was a Velocity template language from Apache Velocity project. Dynamo API Gateway, uses supports that out of the box. Okay, so we started discussing databases, so let's continue with that. One of the offerings is Aurora database. Aurora is developed by AWS and is compatible with MySQL and PostgreSQL. When creating a database, you can choose one of the capacity types, and one of these types is serverless type. And among many things, you can specify the minimum and maximum capacity for that cluster. You can choose also to pause compute capacity after consecutive minutes of inactivity. You will, of course, not lose data. When new connection comes, Aurora will resume its compute capacity after a matter of dozens of seconds. You don't have any master node, you don't have any slave nodes. The only thing you have is endpoint. This is MySQL compatible endpoint. And how it works under the hood is there is a DB fleet and warm pool of DB instances, and if engine needs to scale up or scale down, it just adds or removes some nodes. So as you can see, instances are involved, but it's not your concern. You have only the endpoint you use and nothing else. One thing worth mentioning is that DB cluster is created in a single availability zone, and if that availability zone becomes unavailable, Aurora recreates the cluster in different AZ. In some cases, I guess this is acceptable, but the problem is that failover time is currently undefined because it depends on current demand and capacity availability in AWS zones. And let me remind you this, there is no cloud, it's just someone else's computer. And sometimes you learn it the hard way. Environment health has let me read you the message. Environment health has transitioned from OK to degraded. Auto-scaling activity failed 14 seconds ago with error. We currently do not have sufficient C5 4x large capacity in the availability zone you requested, EU West 1B. That happened to us 1 week ago. The good stuff, there is a new API, data API in beta, deployed in Virginia. So the example I gave you with API Gateway in DynamoDB, the same thing you can do or will shortly be able to do with Aurora Serverless. Okay, as promised, how to run containers in AWS without using any servers. In AWS, we have there is AWS Fargate compute engine for Amazon Elastic Container Service. How it works is that you build a container, you push it to some repository, and in ECS you define details about your containers. More about that in the next slide. And Fargate Compute Engine runs containers, scales them, and stuff like that. So what are the building blocks? You have a task definition when you define your application container, stuff like image URL, CPU and memory constraints, etc. Then we have a task, which is a running instance of a task definition, and all copies of a task are grouped as a service, and service can be exposed behind application load balancer. More on that. Unhealthy containers are detached from the load balancer. Newly created containers after passing initial health checks are automatically attached to load balancer. one interesting note about ALB, you can invoke Lambda functions directly from ALB. So the example with API gateway and Lambda, the same thing will work with ALB and Lambda. So you can also modify, so you can have clients, API gateway, ALB and Lambda. You can have clients, API gateway, ALB, Lambda. So depending on what features you exactly need, because API gateway and API Lambda have a different set of features. One more thing. ECS and Fargate integrate with AWS CloudMap service. CloudMap is something similar to Consul or etcd. It is managed service where you can have all your resources, services, and stuff like that, and you can query it using DNS or API calls. Okay, so we discussed API gateways, service, SQL and NoSQL databases. So let's try with frontend then. For frontend, before we begin, there is S3 service, which is more or less object store similar to Dropbox or Google Drive. But what is interesting about S3 is that you can host your static websites. You cannot, there is no server-side rendering, so PHP and JSP will not work, but for static content, you can use S3. So once you enable it, you will have endpoint you can use. So let's imagine we have this simple HTML file. We will upload it to S3, and then we will use the endpoint we have to see the file. And of course, static files, it's better when you host them on your custom domain. So how you can do is by using another service from AWS. That service is CloudFront, which is CDN content delivery network. So how it works is that requests instead of coming from users to S3, they will go to CloudFront, and CloudFront will request S3. So let's create a distribution. Let's use S3 as an origin for that distribution. You have to specify a domain name for that distribution. You can specify SSL certificate, and you can deploy it. In the meantime, there is a certificate manager service. Something similar to Let's Encrypt, so you can for free request SSL certificates and use them in various AWS resources. And there is Amazon Route 53 service where you can buy domains and manage your DNS records. And this will be exactly what we will do. We will under olxtech.pl domain, we will create DevOpsDays Poznań record that will point to CloudFormation distribution we just created. And thanks to that, our index HTML file can be accessible using our custom domain. And to be clear, that can be also other static files like CSS and JS files. Another interesting product connected with CloudFront and S3 is Lambda at Edge. So with CloudFront and S3, as I said, you can only host static files, but Lambda at Edge allows you to execute Lambda functions on certain CloudFront requests and responses. That requests and responses are viewer request, origin response, and viewer response. You can do pretty interesting stuff using Lambda at Edge. For instance, you can inspect cookies to rewrite URLs to different version of a site for A/B testing, or you can send different objects to your users based on user agent header, which usually contains information about the device that submitted the request. So for example, you can send images in different resolutions to users based on their devices. So the last thing that is left here is message queue. So let's briefly touch that. This is a typical fan-out setup based on RabbitMQ. You have a producer that sends events to fan-out exchange, which then distributes this event to certain queues, and you have consumers that are consuming messages from these queues. And in AWS, you can do a similar setup entirely in serverless manner without any server. For that, you use SNS topic, which is equivalent of Exchange in RabbitMQ. And you can use SQS queues, and SNS topic will distribute events to subscribed SQS queues, and you can have consumers consuming from SQS queues. So no servers to manage, and the good thing is that even you can do this cross-account, cross-region, and stuff like that. Okay, so I believe we discussed everything from the architecture here. Last but not least, there is one interesting service called Amazon CloudWatch, and it provides you with, it gives you the visibility to your cloud resources and applications. There are some predefined dashboards. You can create your own dashboards. You have metrics, and you can create alarms based on these metrics. You can push logs as well to CloudWatch, and it provides you with something called CloudWatch Insights, when you can analyze your logs. There is some domain-specific language for that you can use, and you can even visualize the results of your queries. And here is, for instance, example on filtering EC2 related events from CloudWatch service. That would be all. I think I was able to cover all every possible cover this architecture. Any questions? Or was it too much content? I guess it was quite heavy.
One question?
Yeah.
You got a production solution working in this
Yeah.
mode, using all of these.
So at OLX, we have one product that is entirely serverless. So it is for sure possible, but it is like a rather small product consisting of few features. If I were to build something more complex, then I would think twice, to be honest, because this is quite a new stuff. I would say that provisioning resources is not quite good. There is a lot of things missing in serverless framework and in application in AWS SAM. some DevOps practices you use, things like rolling deployments, canary releases, and things like that. Not every single managed service supports that. So there are cases when you are deploying something, things are not working for a few seconds. For instance, with front end, the problem is that frontend is cached on edge nodes, and invalidating these caches takes quite a time. So if you have to revert frontend, then it can take like 15 minutes, for instance. So it all depends on the specific use case and what risk you can take and accept. Thank you.
Yeah, so we didn't collect any additional questions, so thank you.